In this topic, we'll cover Python regular expressions. You might have heard of regular expressions before. They are generally used with strings in order to find strings that match a specific pattern. Regular expressions are very commonly used if you want to find patterns which match an email address, for example. You want some alphanumeric characters, then the @ sign and a dash.com or a dash.in. Regular expressions can also be used to check for valid phone numbers, valid addresses, and so on. Python offers a very powerful regular expression support in the RE module. RE stands for regular expressions. However, we are only going to touch on the very surface of regular expressions in this particular lecture. Any string can be thought of as a regular expression because a string is basically a pattern. For example, the word test is a pattern. You want to check whether the word test is present in another string. So you will first compile the string test to be a pattern using the re.compile function. Once you have a pattern object, you can check whether other strings match this pattern. For example, pattern.match will check whether the string boo matches this pattern. The pattern had the word test in it. The match function will check whether the string boo starts with the pattern specified by the string test. The string boo doesn't start with test, which means the pattern.match will return none. No pattern was matched, which is why no pattern was returned. Our pattern is the word test. Let's check whether this pattern matches the word test itself. This is clearly a match. Test begins with test, and we get a pattern match object as our return value from pattern.match. The pattern match object contains a number of pieces of information. It says that the span of the string from index 0 to 4 is what matched, and the original pattern which matched was the string test. Our pattern is still the test string. Let's check whether this pattern matches the string test someday. Test someday starts with the word test. This should be a match, and that's what you see on screen. It clearly says that the pattern matched the test someday string. The span of the match was from index 0 to 4. The match function explicitly matches from the beginning of the string. So if you try to match the test pattern with the string some test, the return value will be none because some test does not start with test. Once again, let's prove that the pattern.match function only matches the beginning of the string. This will not be a match as well. Test is present in the middle of the string. It's not a match. The return is none. If you want to match a particular pattern, not just at the beginning of a string, but anywhere within a string, you'll use the pattern.search method. Pattern.search will search the entire string to see if there is a matching pattern. Our pattern was simply the string test, which of course matches the string test. This will return a match object, and the match object will indicate that the pattern was found in the span 0 to 4. Let's do a pattern.search on the some test string. Test is present at the end of the string. When we use the search method, there will be a match. And notice the span of the match is from index 5 to index 9. The search function will find patterns which occur in the middle of strings as well. Here the string test occurs in the middle of the string. This is a matching pattern as well, and you can tell the span of the match is from 5 to 9. Now let's make our patterns a little more interesting because that's what regular expressions are all about. You can specify a pattern which says, I want to match any of these characters. You'll specify square brackets and all the characters that you want matched within square brackets. This regular expression basically says that within a string, you want to find any of the characters A, B, C, D, or E. You specify all of these characters within the square brackets. A string will match this pattern only if it contains one of these characters A through E, all in small case. This pattern is stored in the variable P. Let's find a match with a string which contains only numbers. Remember, the match function only checks the beginning of the string. No match was found. This function returned none. Let's try finding this pattern within another string. The string is A345. It starts with the character A, which is one of the characters that we are looking for within square brackets. A match object is returned, and it clearly says the span of the match is from index 0 to 1, and the match pattern that was found was the letter A. Let's try whether this pattern matches the string that you see on screen. P.match, remember, looks only at the beginning of the string. The beginning of the string is numbers. Clearly, this should not be a match, and none is returned. Instead of the match function, let's say we use the search function to see whether this pattern exists within this string. The search function scans the entire string for matches, and a match is returned. In the span from index 4 to 5, we found the character A, which matches our pattern. Let's call the p.search function once again, but this time we pass in a string which has all numbers except for the single letter G. If you remember our pattern, it considered all characters A through E. It did not consider G, which means this pattern should not be a match, and that's what is returned. Let's set up a new pattern. This time we're interested in searching within a string for all alphabets, whether they are capitalized or in small case. Notice how we can use the dash to specify a range of alphabets, A-Z in smaller case and A-Z in uppercase. Specify these within square brackets to indicate that we want to match any of these characters. Let's perform a match on a string which contains only numbers. This will clearly not be a match, and p.match will return none. What about p.search on a string which contains exactly one alphabet, the letter G? G is present in the range A through Z in smaller case. A match is returned, and the span of the match is from index 4 to 5. Let's try searching for this pattern in another string. We call p.search on a string which contains numbers and two alphabets in uppercase. J is first, and then we have G. Now, there are two alphabets here, which means there are two matching occurrences of the pattern that we are looking for. When we use the search function, only the first occurrence is returned. Notice the match object that is returned matches only the first J character. This is located at index 2. The alphabet G, though it matches our pattern, is not returned as a result of the p.search function. The search function returns only the first matching pattern. It will often be the case, though, that you want all the matching patterns within the string. You can do this using the find all method. P.findAll will find all the matching patterns. The result of find all is a list which gives you all the substrings that matched within our string. The first match was the letter J, the second the letter G. You can see so far that regular expressions are all about using special characters with special meanings within patterns to pattern match your strings. In this example, we'll encounter another special character, the caret sign, or the little arrow that you see. The caret sign means does not start with. So the pattern we want to match, which we've specified within square brackets, is 0 to 9, but we want to find all strings that does not start with 0 to 9. The presence of the caret basically means does not start with. Let's see whether this string matches this pattern. This string starts with numbers, starts with 1 followed by 2. This match should fail. The pattern should not be found, and that's exactly the case here. This pattern is only to find strings which does not start with the numbers 0 through 9. Let's see whether this pattern is found in this string. This string starts with a capital A. It does not start with a number. There should be a match, and the match is at the very beginning. We can use the find all to find all non-numeric pattern matches within this string. This string consists of uppercase letters, lowercase letters, and numbers. All the non-numeric characters will match, which are Z, J, and G. You can make your pattern matching within strings more interesting, more involved by using wildcard characters. When you use the asterisk, that means match 0 or more characters. Let's take a look at the regular expression here. We want to find patterns which start with C, then have A, but A may be present 0 or more times as specified by the asterisk, and our pattern should end with T. We want to find strings which match these patterns. The asterisk means that the character A just before the asterisk can be present 0 or more times. Does the string CT match this pattern? It starts with C, there is no A, and ends with T. This should be a match, and that's what you see in the result. The match is in the span 0 to 2, and the pattern that was matched are the characters C and T. Does this pattern match the beginning of this string? The string is cat. C is present, A is present once, and then T is present, and this is a match as well. Here, the match term within the match object becomes very useful because it specifies the exact string that was matched, cat. Let's try with another string here. It starts with C, it ends with T, and it has A 3 times. Since A can be present 0 or more times, a match is confirmed. It returns a match object. What about this pattern? It starts with C, ends with T, and has a B in between. But our pattern allowed A 0 or more times. CBT will not match. That's why P.match returns none. Remember that the match function always looks for a match at the beginning of the string. So here we have the string ASD cat. Cat is not present at the beginning. There'll be no match. P.match returns none. In order to match anywhere within a string, we'll use the search function. Here we have C followed by 4 A's. That is a match because A can be present 0 or more times. You can use the find all method to find all matches of that pattern within a long string. Here there are multiple matches. Let's see if you can guess what they are. CT, CAT, and CAT. Remember that the matches have to match the case as well. So we have a cat with a capital C. That will not be a match. Regular expressions in Python are incredibly powerful, and what you've seen so far in this video is just a small sampling of what regular expressions can do. If you're going to use it heavily, I suggest you study it further. In fact, you can have an entire course on regular expressions. This serves only as an introduction.